page 47. The old chi-squared. It looks like chai, but it's chi. All right. So I imagine at some point in your life that there might have been something that would have been, make sure you have your stuff out, page 47, please, that you would have had like a cereal box or energy drinks or something that had some sort of contest in which they had some sort of prize that you got because you bought it. So that relates a lot to something that we're going to talk about with the chi-squared test. So many hypothesis tests cover a wide variety of data collection scenarios. So we're going to learn about the chi-squared. So this talks about the entire distribution of data across categories to see if there's evidence or a change in how it's distributed. What it means is they're talking about they have a free special baseball card on each package of Frosted Sugar Bombs. I don't know what the cereal is, but we're going to have it. There are 5 total to collect. So just to make it easy, we'll call them A, B, C, D, and E. So these are special collector's editions cards. And you're like, oh, I don't collect cards. We'll just go with it. So you want to collect the whole set. You want to collect all 5 cards. Now, I will tell you, growing up in life, different restaurants like McDonald's or Burger King, they would have, each week you could come in and get a new cup, and which kind of just similar to your guys' fancy with Starbucks, the holiday cups that come out at Starbucks. You have to get this cup. And then it's going to sit in the cupboard. You can probably look back 6 generations of cups in your cupboard. You guys know what I'm talking about? Yeah. It's like every time something comes out like that, my younger daughter, hey, we got to go to Starbucks to get this cup. Great. Now I have all these cups in my cupboard, and we never use them. But she's happy to get them. So in this particular thing, where you had cards A, B, C, and D, and E, they say you plan to buy 40 boxes of sugar bombs. Now, you could go in and just grab 40 boxes off the shelf. You could go to 40 different stores, selecting a random sample of boxes of the cereal that have these particular baseball cards in it, or anywhere in between. We get our 40 boxes. We have 11, and we got all the prizes out of each of the 40 boxes. There's 11 cards in that are the A card. There are 7 of the B card, 6 of the C card, 9 of the D, and 7 of the E card. So it seems to be that in our selection of our 40 boxes, that the C card is the hardest one to get because we got the least amount. So does this scenario make sense? We're collecting baseball cards, basketball cards, football cards, whatever, something that you want to have in possession. So if you were to have a selection of 5 different things and you were to collect 40, or you went and got 40 boxes, you would hope to get 8, 8, 8, 8, and 8, because 8 times 5 is 40. Agree? So the expected value on this is if I bought 40 boxes, I would get 8 of each. Okay? So, as always, you need to evaluate the breakdown of statistical evidence. Does this data represent real evidence or just randomness? So remember, the null hypothesis means no difference or no change. In this case, the null hypothesis would be that 5 cards are equally likely to occur. No difference in the rarity. The alternate hypothesis would be that 5 cards are not equally likely to occur. So our null would be 5 cards are equally likely to occur. Our alternative, the 5 cards are not equally likely to occur. Okay, so there was a game years ago by Coca-Cola. Now, I'm going to kid you not, this is going to go way back when. This is before plastic bottles. You used to have to get Coca-Cola in a glass bottle. And I will tell you, Coca-Cola in a glass bottle tastes better, in my opinion, than Coca-Cola in a plastic bottle. So under each of the caps, Coca-Cola was having a contest. And under one of the lids was Coke, and then another lid was another one was real, And the last one was thing. So if you could spell out Coke the real thing. Coke the real thing. Yeah, Coke the real thing. 4 letters or 4 words. You would win $1,000. Now this is back in the late 70s, so $1,000 was, that was
like 1.2 million today.
Yeah, like put in perspective, that $1,000. If I went to Arizona State University in 1979, my entire year of tuition and books would cost me less than $500. I know some of you are coming up on looking at prospective schools that you might be going to. School is expensive. I can tell you I'm very thankful that my oldest daughter is in graduate school and she's on the full ride. My younger daughter, she's at Purdue. And I'm glad that she's an RA. If she wasn't an RA, I'd still be paying $45,000 a year for her to go to Purdue. Now it's just north of $20,000. But still, it is what it is. But if you could spell out Coke the real thing with your bottle caps, and you brought it into the store and you showed them, look, it says Coke the real thing, and you had these 4 caps that spelled it out, you won $1,000. Well, I can tell you in that particular event, there was one word that was harder to get. So they got all this excitement and people were buying things like crazy, talking to your neighbors like, hey, we got the word Coke, and someone's like, oh, we got thing. Oh man, that's awesome. Let's get our minds together so when we buy soda, we can maybe win this and we'll split $1,000. Well, the word real is the hardest one to get. In fact, of all the people that I ever met in elementary school when this was taking place, there wasn't one person that said, hey, look, we spelled it out $1,000. So in that particular case, it was not a fair distribution of the 4 words, Coke, the real thing. But in this case, they're saying, hey, we bought 40 boxes of cereal. There are these 5 different baseball cards. We want to know, is it an equal chance that any one of these baseball cards that we buy a box of cereal, I should have a 1 in 5 chance of getting any of these particular baseball cards. Okay, so the no 5 cards are equally likely. The alternative that they're not equally likely. Okay, so after that, you create something called a side-by-side breakdown. So I'm going to generate this for us, just to make sure we feel comfortable with it. So we have card A, card B, card C, D, and E. And I don't know what these cards are. But then we have our observed, and they told us that there was 11 A's, and this was our random selection, our selection of these boxes, 7 B's, 6 C's, and our D's were 9, and our E's were 7, and we have an expected value. We would think that we should get, of our 40 boxes, 8 of each. Okay, if they were equally distributed, that should work, but it is a possibility that they have one card that's more rare than others that they might not put into play. But that's what our chi-square test as we progress through this chapter will start justifying. Our goal is to be handled in several next few assignments, not to evaluate the 2 distribution, to see if strong evidence exists that these cards are not equally rare. Okay, so we're following the adventure. All right. All right, example 2 says we have this distribution of blood types across the world is well known as follows. Blood type O, 45% of the population has. Blood type A, 40%. Blood type B is 11%. Blood type AB is 4%. And we wonder if the percentage of breakdown of blood types in Colorado is the same. We collect a random sample. Okay, we like the word random. Random sample 200. 200 is a good amount of Coloradans. To obtain the following, they have a blood type of 95 out of the 200 have type O. 77 have out of the 200 have A. 23 out of the 200 have B, and 5 out of the 200 have AB. So our null hypothesis and our alternative, so the blood type distribution is the same as the rest of the world. you know, percentage-wise. The blood type distribution is different than the rest of the world. All right, so you have to do a little bit of math on this, which is not tough, especially with having calculators. So what they're looking at here, we have to figure out, because originally they gave us the percents, correct? All right, so we have blood type, blood, maybe we should do it in red. So we have O, A, B, and AB. And we have an observed amount. So we have 95, 77, 23, and 5. And we have the expected value, which was, this came from the world. The expected was 90, 80, 22, and 8. Okay, so if this is true, oh, okay, I made it. So they were saying that this would have been 45%. This would have been 40% as far as the world distribution goes, 11% and 4%. So if we were to do all these, you'd go multiply 90 times 45, or 45 times 200, times 200, times 200, times 200. And let me just verify that our number is right. Yes, it is right. Okay, so what they're doing, so these were the percentages, the 45, 40, 11, and 4%. Those were the percents. Being that we had 200 people, you have 45 times 200, so you're hoping that 90 people had a type O. We happen to find in our sample that 95 out of the 200. 40% of 200 is 80. So we got 77. 11% of 200 is 22. We got 23, and 4% of 200 is 8, which is 5. So it says our observed counts are somewhat different than the expected counts. Is there evidence in this data that the blood type distribution is different? So again, future assignments are coming up. So this was just kind of a basic idea. So things that you have to look out for on these is, did they give you a percent? And if so, yeah, the percent, you have to multiply your percent by to find your expected value. So that's where the 90, 80, 22, and 8 came from. And 200 came from, that was our sample size. And then we have our observed. So these will start tying together over and over and over throughout the rest of this unit. Planning this unit to take us about 3 weeks. Cool. And we'll have our first quiz on this on Friday. And again, that quiz will be on Schoology. I think you'll like this quiz. I think it's good. So, hey, anyone travel real far on their adventure of spring break? We had